So I'm here at test.k6.io, and let's imagine that this is our application and we want to do a smoke test. So of course, we can do this manually, right? We can go to the website and check a few pages. There's like this contact page. There's also some news. So there are different pages that we can check. But if we want to automate everything, we should write the test in K6. So let's see how we can do that with the K6 script. We can simply go ahead and duplicate our initial script. I'm going to go ahead and rename it in smoke test. Let's go ahead and close this. So what do we have here? Well, we have a few basics, like we are importing everything that we need. We have the options. In this case, because we are doing a smoke test, only one virtual user is absolutely enough. And let's say we want to run this for 30 seconds. 30 seconds is generally a good duration. And we already have here the start page. So in our default function, we are visiting the start page. But just as well, we could visit other pages, right? So it's an entire application. It doesn't have just a single page. So let's check if the contacts and the news work. I'm going to go ahead and grab the addresses. From the website, I'm going to go to contacts. And from the address bar, copy this. So just below sleep, I'm going to use http://get. And between single quotes, I'm going to put the address. Let's go ahead and add 2 seconds sleep after this. We don't always need to use the same value for sleep. So that would be a good value to use. And going back to the website, let's also check the news. I'm going to click on news, copy that address, and again use http://get. And between single quotes, I'm going to put the address. Make sure not to have any errors in the code. And again, let's add a 2 second sleep after these pages. So to run this, K6 run, and I'm going to use the smoke test. I don't want you to wait for 30 seconds, so I'm just going to go ahead and fast forward this to the results. So the execution is done, and probably the most important thing that we want to see is the failed HTTP request. So you'll see here that 0% of the requests have failed. You will see here, again, in absolute numbers, 0 have failed, 18 have been successful. So in this case, the check is for the failed ones and the X is for the successful ones. But we want to have no failed requests essentially for a smoke test. So that's already a good sign. Now, of course, we can also take a look at the other metrics that we have here. For example, the duration. I said earlier, this is probably not going to get any better. So if in our system there are no external sources of traffic and we only run the smoke test, these are the best values that we will get, because as we start having more users, of course, the time it takes the server to respond will be then higher. Okay, so we'll see here in this scenario also how many requests we have sent. And of course, if you have the impression that there are too many requests that are being sent in this period, this is also something that we may want to control. So totally up to you. And also of interest would be the number of iterations. So in this case, we had 6 iterations, meaning that our virtual user went inside the default function 6 times. So we started the default functions 6 times, meaning it goes to this page, waits 1 second, then goes to this page, waits 1 second, and then goes to this page. So if in case you think, oh, there are too many iterations or there are too many requests that are being executed in this period of time, for a smoke test, of course, you can control that as well. Now, next, I wanted to go a bit into what it means for a smoke test to fail. So I'm just going to give you an example. So there can be the case that the server is offline. So I'm going to replace here IO with local. So this would be like an address that doesn't exist. And it somehow can simulate that the server is offline. Again, I'm going to fast forward this so that we can take a look at the report to see what has happened. Now, even before this has completed, I want you to notice something. First of all, this request has failed. So this is something that's important to look at. Apart from this, I want you to also notice that the number of iterations has also decreased. So essentially, K6 has tried to open this address and it is like an internal timeout. So it has waited a bit for it, hasn't responded, and only then went to the next page. So this means that the total number of requests that we have executed is also smaller in this case, something to be considered. Apart from this, if we're looking at the failed requests, we're going to see here 3 requests have failed, 6 have been successful. So 33 of the requests have failed. Of course, this is an induced failure. Apart from this, it's always a good idea to see if there are any warnings. So if you see here warnings, definitely try to understand what is going on there, because there shouldn't be any warnings when you're running a smoke test. All right, I'm going to revert it back to .io, and let's create something more, how can I say, realistic. So in this case, let's say that this page contacts has been deleted. Now, of course, I don't have access to the server to physically delete it, but I'm going to change the address here from contacts plural to contact singular. So I'm going to remove one S. So if we take this address and go to a browser, I'm going to go ahead here in the browser and paste contact.php. What we're going to get back is file not found. Now, what this server is actually giving back is telling us, this is a response from the server, hey, look, this page doesn't exist. So let's see how K6 will handle this scenario. So again, I'm going to start a test, and let's wait a bit to see the results. All right, so going back, this time we still have 6 iterations, and essentially the number of requests that we have sent is pretty much the same as before we introduced the server error. And again, we're having here 33% of the requests that are failing. So why is this failing? How do we know that this is the case? Well, because the server is sending a 404 status code, is essentially signaling to K6, hey, this is a response from me, and I'm telling you this page doesn't exist. So when K6 receives the status code, it understands, well, you actually wanted this page to exist, and it doesn't exist. So the request has failed, and I'm showing you here in the report so that you can be aware of this. Of course, just from the report itself, we don't know exactly which is the address that is causing us problems. That is something that we will address in the upcoming lectures. But just by looking at these details, we already understand there's a problem there. We need to dig deeper into this to understand what is happening. So just by looking at this, HTTP request failed. We have a few that failed. Why have they failed? We need to investigate. The same thing goes with scripts. So if they have any errors in your script here, they will most likely cause the script to fail, or you will get here warnings when you're starting the execution. So be aware of any warnings. Do not simply ignore warnings. Try to understand why are they coming, and always build your script step by step. If all of a sudden a warning shows up and it didn't show up before, try to understand why that is the case. Now, last but not least, just to recap, a smoke test is not a performance test. So we have only used one virtual user, and we have used the duration of 30 seconds. For this application, this is enough to understand if it is working or not. So we have used the smoke test here just to test our code and the application to see if everything is up and running. We want to check if the scenario that we have here with all the sleeps and everything work as expected. If we're getting like the expected number of requests, one virtual user should generate. So we don't want to have something that's totally unreasonable, like one user sending in 1 second 10 requests or something like that. Can be the case, but for example, for this website, that would be very, very unlikely. So in this process, we have put the application only under a minimal load. I've used 1 user. It's also okay to use maybe 2 users or 3 users, but if you're more than 3 users, it's already not a smoke test. It is getting into something else. And again, the duration. A duration of 30 seconds, I would say it's kind of like typical. Of course, it depends on the application itself. If you have a lot of pages that you need to go through, you have a more complex scenario, of course, it makes sense to increase that duration. You really want to check like how many iterations you have, right? So you should be able to get at least through 1 iteration. Ideally, 2 or 3 iterations would be ideal. But don't try to have something that's running for 30 minutes, because that again is not a smoke test anymore. And this takes me to the next point, and that is because these tests are so fast, they only take 30 seconds or something like that, are very efficient, and we get quick results, and it saves us a lot of time, so we don't need to worry too much about it. And it also helps us understand like how does this application perform. We get some baseline values, because we know by looking at these values here, they will not get any better once we start sending more users. And I would say a bonus of having this smoke test is that We can use K6 to monitor a production system by running these tests at regular intervals, typically through a CI/CD server. So essentially, we can take this test and run it every few minutes, right? So if we know that the test only takes 30 seconds, we can run it every minute or every 2 minutes just to check how is the application doing? Is everything working as expected? And we can run this on a production system because the kind of load that we're putting on it is almost insignificant.